This video is about the rebar object, and what we will learn is basically how to enter a basic rebar completely manually. We won't be talking about some of the more complicated or advanced commands, but basic just the point-based rebar entry in which everything is in our control, and then actually delving deeper into it and seeing what the dialog box looks like and what properties we can set for a rebar. So let's start by entering a rebar so that we know how we can enter a rebar in Commosys. So if you go to the concrete menu, over here we have the rebar command, and inside we have these two options of creating a rebar group or creating a single rebar. Now, you might say that in concrete it's always a rebar group. Why would we place a single rebar? Well, you might need to place a single rebar for other reasons. Some other commands might be using a single rebar as input to do something with that, or to extrude that, for instance, or basically do any operation on that. But let's focus on the create rebar group, which is basically a rebar and then it has a range. So if I were to select this command, the first thing which it asks me is for a parent object. And this is basically the assembly or the main part of the assembly to which this particular rebar will belong to, with which it will be drawn in the drawings. So let me select the slab over here, and now it turns to the point selection mode, and you can see over here also select a path point, and the path of the rebar is basically the shape of the rebar. So let me create a rebar which goes from here to here to here and then down, and that would be my path. So let's start selecting the points. Let me select the first point, the second point, the third point, the fourth point. It's going to keep continue asking because it has to consist of at least 2 points, but it can be as many points as you want. So when you're finally done with that, you need to right click to show that you're done entering the path points. And that now it says select from point and 2 points. So this is now the range. So this rebar, which we defined like this, what will be the range along which it will be placed. So for that, I select this point as the first point and this point as the last point. And when I do that, it still asks me for a Y direction, which I don't need to enter in this case. So I can just right click. And when I do that, immediately a set of rebars is created. Now that we've created the basic rebar, let's double click on the object to open up the dialog box. And the first thing we want to talk about is the diameter. So there are two diameters, the diameter and the actual diameter. This is more like one is what you write on the drawings and one is the actual modeling. And usually they're both the same. So let's convert those two into 20 millimeters so that it looks a bit bigger. And when you say apply, then the diameter of the rebar changes. Now let's move on to these variables related to the cover distances on the right hand side, and these are important. Right now, if I were to turn this off and I were to look at it from the side, let me go and turn it completely to the side and zoom in, you would see that my rebar is placed exactly at the path points. These are my path points from here to the other side, and it's placed exactly at those path points. If I were to double click on the rebar and enter a cover, this is basically the clear cover. So right now it's 0. So if I were to enter a clear cover of 50 millimeters and say OK, you will notice that immediately a clear cover has been provided to the rebar, which is of 50 millimeters from all sides, except for the start point, which stays where it was, and the end point, which stays where it was as well. But basically the segments, the first, the second, and the third segment have been pulled in by an amount of 50 millimeters. Now, this 50 millimeters which we enter over there can actually be a variable as well, in the sense that you can actually have a different clear cover for each of the segments. So there are 3 segments of this bar. This is the terminology used in Comosis. We call these segments. So this is segment number 1, this is segment number 2, and this is segment number 3. And we can actually have a different clear cover for each segment. So if I were to say 50, 100, 50, what that will tell Comosis is use 50 millimeters for the first segment, 100 for the second, and 50 for the third. And if I were to do that, you will see that we have a 50 millimeter clear cover for the first segment, 100 for the second, and 50 for the third. And let's go in and actually measure this. So if I were to say measure distance and actually measure from here to here, you will see that it is 60 millimeters, since the bar itself is 20 millimeters and half the bar is 10. So the 50 which we had is actually till the edge of the bar, which is what a clear cover is supposed to be. It's not supposed to be the distance from the outer edge to the center of the bar, but rather to the edge of the bar. So to the center it is 60, but to the edge it will be 50 millimeters. And the same is true for this 100. Now, another thing which you can do with this is, if I were to double click again, is to actually give a negative clear cover if you wanted to. So if I were to say 50 minus 150, then the second leg will actually come out of the concrete. And by using this feature, you can modify your clear covers depending on your needs. Now, one thing which needs to be said in the simple cases which are convex, we will usually see that the positive numbers would mean going inside the concrete and negative numbers would mean going outside the concrete. But sometimes the bars can be cranked, or they can be concave, or they can be of a nature in which the local directions might switch. So it might be that you might have to give a minus sign or a positive sign depending on the shape of the bar. But either way, you should be able to get the result which you want. So let's now bring this back to 50 and move on to the next variable. The next thing which I want to talk about are these start offsets and end offsets. So if you remember, the start offsets remained where they were. The start points remained where they were. If I were to give this a start offset of 50 and say apply, you will see that the start point is pulled back by an amount of 50. And I can do the same for my other side. And this time the clear cover is provided for the edge, for the last point as well. So normally if you want to give a clear cover, you would enter that number over here, and you would also enter the same number in the start and end offsets so that you get a clear cover from all sides. Now, once again, these numbers can be minus as well. So if I were to give a minus, you would actually end up sticking the bar, pushing the bar outside the concrete. You can give a larger number as well. So you can have something like this. Or like I said, you can just give the same as the clear cover, and then you will have what we will typically do in reinforced concrete. Now, after that, what we are left with is this 0 over here, which is for the range. And what that represents, I can very easily see if I were to rotate this and look at the thing from the top. And you will see that from the top, the first bar is right at the edge over here, because when we were creating these bars, you remember for the range we entered this point and the final point over here. So the bars are placed from that point to that point, and they're not pulled back according to the clear cover. So if I were to double click on that, we have this range clear cover, and if I were to give 50 to that as well, then you will see that the bar is now pulled back. And once again, if I were to measure this, the distance is 60. So the clear cover is actually 50. And this 50 has been applied to the start as well as to the start as well as to the other side, which is the end. And once again, like the clear cover, you could break down into several segments. The range also you can modify, so you can have a different value for the start and maybe a different value for the end. So if I were to say that you have a clear cover of 50 at the start, but a clear cover of 250 at the end, what that will mean is that the last bar is placed 250 behind the endpoint of the range. Now that we are familiar with these cover distances, so we talked about the clear cover, the range, start offset, and the end offset. Let's talk about this group over here, which is to do with the hooks at the start and the hook at the end. So the start point of the rebar can have a hook if we want it to have a hook, or it cannot have a hook. And that will depend on whether this particular flag is checked or not. So if I were to check this flag, then a hook will be created at this end according to these three variables. And what these three variables tell us is what the bending radius of the hook will be. So it'll obviously be bent. The second thing it tells us is what the angle of the hook will be. So if it's a 135-degree hook, it'll be something like this. And the third thing which it tells us is the distance of the hook, which is let's say it's a 135-degree hook. So it's going to go like that. It's going to come up. And then after it's the 135-degree point has been reached, it's going to straighten up. And the distance which it travels after straightening up is called the distance variable over here. So these three variables basically define what a hook looks like. So right now the hook is 150 millimeters of straight length, 50 millimeter bending radius, and 135 degree angle. So let's create, if we were to create a start hook, we will see, if we say apply, we say that the hook is created. It was the end of our rebar was over here. We asked for a 135-degree angle at a radius of 50 millimeters. So from the point was already pulled back 50 from the edge. So from there, the radius of 50 means it's going to go 50 like that. The radius would be 50. And since the thickness of the bar itself is 20, so it's coming out a bit from that side as well. So the radius is 50, the center line radius rather. And then the angle is 135, and then it goes another 150. So if I were to reduce this 150 to say 100, you will see that this length will be shortened. Now, obviously, we don't want the hook to come out of the concrete like that. We actually wanted it to go something like that in a way that the clear cover would still be 50. Now, to do that, a very simple way to do that is to modify the start offset by an amount which is equal to, so you add a number which is equal to the radius plus half of the diameter of the bar. So the radius is 50 and half of that is 10. So if you add 60 to this, so if I were to add 60 to that, it would be 110. And if I were to say apply, then we will get the hook exactly where we want it, the place where we want it. So now this is the clear cover once again, which is 50. And the hook has also been created. The same thing can be done for the other side as well. For example, if I wanted a hook on the other side as well, then what I would do is I would put an end offset of 110 as well, because these numbers, I will basically add 50 plus 10 to whatever number is already here. And if I do that, then I will get my end hook as well. And by using these variables, I can quickly create or not create my hooks. Now let's double click once again and open up the dialog box and check some of these variables over here. So every rebar can have a name, just like any other object in COMOSIS. You can use the name variable for filtering later on. But the more important variables are the ones over here. So this one is the prefix for the numbering, as you're already familiar with what the numbering feature in COMOSIS does. It will take the P and it will take the start number as the CD start number, and then it will number all the rebars, P1, P2, P3, P4, depending on your choice of prefix and your choice of the starting number. And it will give them an actual number. So these are important fields. Similarly, you can give every rebar a class number if you want. This is just an integer. What's more important are these two over here. And so this one basically says the parent type. So every rebar will belong to an assembly. There will be a part which you will in your mind will be thinking of as the main part. So this rebar, for example, if it belongs to a slab, you can say that the parent type is a slab, and you have different parent types to choose from. You can leave it at general, which is default, But you can say this rebar belongs to a column or a beam or a slab or a wall or a parapet or a column corbel, a wall corbel, staircase, tie beam, pad footing, strip footing, raft foundation. Several other types are available, but if none of them fit, then you can also leave it as general. And obviously these are for your filtering later on, both in the model and in the drawings, because these will really facilitate which rebars you want to show, which rebars you want to turn off, etc. Similarly, there's a parent ID. So while the parent type is a slab, what is the ID of that slab? So this number over here is automatically filled in, because if you remember when we created the rebar, we first selected the slab. So at that instant, this parent ID was entered automatically by the program. So you won't need to change it normally when you're creating rebars. This number will be automatically filled. You just need to know that 3428 is basically the ID of this slab. The other type is over here, which is basically the type of the rebar itself. And usually the most common types are the top main reinforcement, the top secondary reinforcement, the bottom main, the bottom secondary, longitudinal stirrups, cross ties. Those are the most commonly used rebar types. So if I were to open this, you have all these different options of stirrups, top main, top secondary, bottom main, bottom secondary, longitudinal chairs, anchor bolts, depending on, I mean, we've got lots of options, cross ties, mesh reinforcement. But basically, you can set any rebar type. And once again, the main purpose of setting this type is for filtering in the drawings and for filtering on the modeling side as well. Because rebars can very quickly start to look like a jungle. And the better way of doing 3D rebar detailing is to continuously ensure that you are entering the right rebar types and the right parent types, so that you can easily and very quickly filter the rebars as you go, and that will really make your job a lot easier. Now that we've discussed most of what we see on this page over here, let's move on to this placement tab. Right now we were on the general tab, which had the diameter and the hook settings and the cover distances and the rebar types, etc. And by the way, over here we have the bending radius multiplier. So if you enter 3 over here, for example, what it'll tell is that whenever there's a bend in the rebar, it should be 3 times the diameter, the bending radius. If you leave it by default, it'll take it from a file, and it shows you what the current value is. But if you can override that file as well, the value taken from that file as well. But let's move on to this tab over here, which is called the placement tab. And this has a lot of detail regarding how these spacings are calculated. So let's move on to the placement tab. And as you can see, there are 3 methods over here. One is called the distance method, one is called the count method, and one is called the variable distance method. And we can use all 3, but the standard one, which is used most often, is the distance variable, in which you enter a distance. In this case, it is 500 millimeters, and you tell Comosys to place the bars according to that information. Now, the distance, the actual space available, or the range points which you choose after reducing the range limits. So in our case, if you remember, we had pulled back the range 50 millimeters from both sides. So after doing that, whatever is left, whatever distance is left. So let me go and measure that distance, for example, right now. If I were to measure the distance, not from there, but from this bar to this bar, it's 5,880 center to center. Now, whatever this distance is, if I were to open the dialog box again, whatever this distance is, we want it to be placed at 500. The bars to be placed at a distance of 500 center to center. Now, this distance might not be divisible by 500. So while we want a distance of 500 between the bars, if the distance is not divisible by 500, then it's an impossible task to achieve. So by default, what it will do is it's going to create a distance which is actually slightly less than 500. As little less as close to 500 as possible, but not more than 500, because this number comes from your analysis, so you don't want to under design. If anything, you want to slightly over design. So since the number is also not divisible by 500, what it'll do is it'll go for a number which is slightly less. So if I were to go in and actually measure the distance between the bars right now, you will see that it's 490 at the moment, and it's all of them are for multiples of 490 at the moment. And this is basically the distance which it found, which would fit between those variables and which would be slightly less than 500. Now, there are several options you can use over here. The first thing is normally it would have this option open, forced to put the start and end. If I were to not check this box, then see what happens. If I were to uncheck this box, normally this is open by default. But if I were to uncheck it and say apply, you will see that the last bar is removed, because now I have not forced it to put the last bar, basically, depending on this variable as well, but we'll talk about that in a second. So now what it has done is, if I were to right click and go measure distance once again, now instead of the 490, they're 500. It's exact 500, because what I'm telling it now is to actually go and let me measure it again. Let's measure this point, 500, 1000, 1500. So they're all spaced at 500. But now it's impossible to place the last bar, because the last distance after that, if I were to go from here to here, it's 444. And if it were to place the next bar, it will go outside. So by using this option of, by removing this flag rather, of forced to put the start and end bar, I'm actually allowing it to go for the exact spacing, which is 500, but then at the cost of not putting the first or the last bar, depending on which option I choose from here. So I have this option of not forcing to put the first and the start bar, but then getting the exact spacing which I want. The other thing which I can do is I can force it to put the start and the first bar. In that case, the first and the last bar will be placed, but now the spacing is now less than 500. Now what I can do is I can even with this option, I can actually ask for an exact spacing. What does that mean? How can I exactly do? I can force for an exact spacing rather. And what this does is it tells the program that no, I insist on a 500 millimeter spacing, but keep the last one. So start from the beginning, go 500, 500, and whatever is left at the end for the last bar, just leave it as it is. So this from start basically is telling me that you start with, from the start point, you start with 500s, and then keep going until you reach the end of the limit. And then the last distance between the two bars can be any number. So if I were to right click and say measure distance, I will see that now my distances are 500, 500, 500, 500. But the last one over there, the distance between that bar and that bar is 380. And this is what I had asked the program to do. If I were to double click on that again and go to the placement, I can ask it to do it in reverse. I can say, okay, start from the end backwards, and then say apply. In that case, it will be 500 from the end, and the last bar on this side will be whatever it is, whatever is left. Or I can select the third option of saying center, in which case all the bars will be 500, but the first and the last bars will be different. So we have these three options. That is when we force it for the exact spacing. Otherwise, if we don't force it for the exact spacing, then it becomes a distance of whatever is. They'll all be the same, but they'll be slightly less than 500. But if you force the exact spacing, then all of them will be 500 except for the first, or except for the last, or except for the first and last. So these are very useful options with which you can control the behavior of how the bars will be placed. Now, the next thing you can do is, instead of using the distance variable, you can use the count variable. And when you do that, then you have to enter this field over here, and you can say, I want 10 bars. and in this case, you have to enter the number of bars rather than the distance. And when you apply that, then what it'll do is it'll place 10 bars equidistantly between the 2 points. And the third option, which is a variable distance option, is calculated automatically, usually by the program when it's doing when certain macros are being used. But normally, what you will do is you will use either the distance variable or the count variable to play around with these numbers. Now, if you were to actually use the variable distance field manually, which is normally not recommended, but you can do that, you can go to the variable distance one, and this time you will need to actually enter the actual distances. So for the first distance between the bars, you can say 500, and these will be absolute, not relative, but absolute. So the next one is 750. So that means there will be distance of 250 between the next bar, and the next one is placed at 1340, and the next one is placed at 2000. And if I just were to press apply right now, you will see that the distances are 500, then 750, the total one, then the total of 1340, and a total of 2000. So if you wanted, you could enter these distances manually as well. But like I said, these are for special occasions when you want a very customized placement in a special situation. Normally, what you would be doing is you would be entering the distance, or you would be entering the count, and you would be just asking Comosys to place them automatically. Like I said, you've got several options from start, from end, centering. You can force exact spacing and then use these options, or you can not force exact spacing. Then you can force to put the start and the end bars, and these are the variables you can play with. Now I want to just quickly mention a few things about these two over here. I will have a separate video on the couplers option. So if I were to go inside there, you have options of having a start detail and an end detail for the rebar, and you can set the various types, whether you want a coupler, a female, male, a threaded one, or an anchor. You can have types, whether it's standard type or a bridging type or a transition type, or there are several options available, and then you can have product codes and some geometric parameters for each one of them. And depending on what numbers and what fields you choose over here, the program, what it can do is it can actually draw those couplers in the drawings without you actually needing to model the couplers. Now, there's an option in Comosys where you can actually model the couplers as well if you want to. But since there are literally hundreds of thousands of those couplers, and if you don't want to unnecessarily clutter your model or unnecessarily make your model very memory intensive, then what you can do is you can just enter those variables which we just discussed. We'll do a separate video on this so that you can understand that further. But the whole idea is that you can set these numbers, set these parameters, and in the drawings you will see those couplers, but they will not be in the model. But if you do want to see them in the model as well, for whatever purposes, maybe clash checks or something like that, and then you can actually model them as well. The user-defined attributes are once again the subject of a separate video, because these are across the board. You can add as many user-defined attributes to all the objects in Comosys, not just rebars, to frames, to bolts, to anything you want. And those user-defined attributes can then be used for filtering or for other purposes. What is important for the purpose of this video is the drawing group, which I have discussed in other objects as well. This is to do with numbering. That whenever you do a numbering, the first thing the program does is it sorts the objects in the model according to their drawing groups, and then you can decide whether you want to number a particular group or not. By default, all rebars are created with a drawing group of 2, but you can modify this for any rebars. You can modify this for some of the rebars, depending on what your numbering needs are. Now, one thing I want to talk about is this option over here, which tells you what kind of a bar this is. And the one I've created on the screen is a straight bar. And what does that mean? So for that, to see what that means and to see the kind of things we can do with that, is to turn on your handles first. These are your handles. If I were to turn them on, then if I were to select the rebar, you would see this blue, this line over here, and there is one of those, right? So this basically represents the path. This is the path which we, if you remember, which we chose when we were entering the rebar. If you remember, I had chosen this point, then this point, and this point, and the actual rebar is offsetted depending on what my clear cover parameters, etc., are. But the actual path which I chose is showing on the screen as well. And if I were to double click on the rebar and convert it from a straight bar to a linear taper and say okay, what you will see is that if I were to select the rebar again, what you will see is that now we have two paths. So previously there was one path which was showing, but now there's another one which is showing at the end as well. So that's the difference, that and we need to understand why we have two paths. What that is basically telling me is that now instead of having a straight path along the range, I can have a variable path which can be tapered, linearly tapered. So for example, if I were to select this and select the end path, and I will talk about these in a separate video, how to use the handles, but I'm just going to show them. If I were to move them, then what this shows is that now I can have a separate path for the first bar and a separate path for the last bar. So there are two paths between which the rebars are being interpolated. There's a first path and there's a last path. And this is the meaning of having a linear tapered one. So let me undo that. And the third option which we have over there is the circular tapered path, which will basically give me the option of moving three paths, one at the beginning, one somewhere in the middle, and one at the end. And what I can do with these now is if I only move the center one, for example, then a circular tapering is achieved for the bars. So this is an important property of the rebar dialog box, that you can set the type from straight to linear taper to circular tapered, and then there's a whole world with what you can do with those three settings. But the purpose of this video is to basically let you know that we have these three options which you can use to create what kind of a range, along what kind of a range the bar will be extruded, whether it will be a straight range or a linearly tapered range, or will it be a circularly tapered range. One final thing before we wrap up this video regarding the rebar object itself, and that is that normally in Comosys you have this double clicking option where the full dialog box of the object appears. This applies for all objects, beams, columns, slabs, rebars, generic solids, and everything. But with rebars we have this this quick editing option. So if we select the rebar while the handles are turned on, by the way, so the handles need to be turned on, and if they're turned on, then you have this little gear symbol which appears. And what you can do with it is you can click on it and it will open this small box which will be from the most frequently used fields of rebars will be brought. So for example, if you were to change the diameter to 30 and say enter, the diameter will be changed from there. Similarly, if you were to change the type, for example, so you can change it from top main to top secondary, for example, and it will immediately change the type. Similarly, if you want to change the inter-bar distances from 500 to 250, for example, and enter, your distance would be changed. If you wanted to place it by count, then the count variable would be used instead of the distance variable. If you want to go to distance, the distance variable would be chosen. If you wanted to enter variable distances, you could just enter them directly over here. If you wanted to give the start hook or the end hook, you could turn them on and off from here. And similarly, you could also change the color of the bar immediately by selecting a different color. So this little floating toolbar is basically just a quick access way of getting to the most frequently used fields in rebars, and we'll be adding these this kind of a quick editing or frequently accessed field toolbars for the other objects in Comosys as well. But right now it's available for the rebar, so you can use that. And like I said, in some cases you have to write a number and press enter. for the field to change. And for others, you just need to basically select a different one, and the moment you select it, immediately it will be applied. For example, the color. If I change the color, immediately the color changes. So this is a nice way of having a quick access to your rebar object. And with that, we basically come to the end of the rebar object itself. The purpose of this video was to only explain the dialog box and the basic fields of this object. Obviously, we're going to be doing a lot more discussion on the rebar object by using the various commands which we have for creating rebar objects, and a lot of other macros regarding things like surface macros, operations, and container macros. But those will be the topic of another video. For this video, the purpose is to basically make you understand what the rebar object itself is all about.